Hey everybody, Mr. Judson here. This next section that we're going to go into really is about graphing all of the basic functions. And so our number one goal in this section is, and we're not going to start with graphing today, but really the overall goal is to become very good at graphing things like parabolas and square root functions. They include lines, linear equations in there, but I think we should already be good at that. That's something we've been doing since pre-algebra days, all right? But absolute value functions, cubic functions, all the basic ones, we want to become very good at graphing those. And so the first part of this section really is kind of more problems about finding the equation of a line, but also introducing some of those basic functions and what they look like, graphing those on the graphing calculator, and not by hand but with a calculator, and then also dealing with what's called a greatest integer function. That might be something new to us. Okay. So our first question here is they want us to write a linear function for f of 2 equals 5 and f of negative 1 equals 3, negative 3. And one of the things that always jumps into my head the moment I see linear is y equals mx plus b, and the only way I can get that is I got to know a slope and a point. Okay, it's always the first thing that comes into my head when I see that word linear. So I want you guys to see if you can find that linear equation. Go ahead and try it. All right, so we've said this before, that this is an x value that's getting plugged in. This is the y value that you get back. So really this is just 2 comma 5. And this point over here is negative 1 comma negative 3. Well, if I have 2 points, I should be good to go on this. I mean, this should be easy for me. I just said a second ago, I need a slope and a point. Got my points. Now I just need a slope. So we're going to say that m equals y2 minus y1, negative 3 minus 5, that would be a negative 8, over x2 minus x1. So a negative 1 minus 2, that would be a negative 3. Negative divided by negative is positive, so there's my slope, 8/3. And so now I just need to pick one of the points to work with. And so I'm going to go ahead and pick this one. I always avoid negative numbers if I can. I think in life it just makes it easier. And remember, I am always using point-slope form. We talked about this last week, that I think some of us really ought to consider using this because we're not getting the right answers. We want to make sure we get the right answer, and more people are successful with this than with anything else. Okay? So my equation is going to be y minus the y value equals my slope, 8/3, times x minus the x value, which is 2. And now I just have to solve for y, get y by itself. So first I'll distribute this. Y minus 5 equals 8/3 x minus 16/3. Remember, integers, you just multiply straight into the numerator. And now I got to move this 5 to the other side and add that. So I'm just going to say when I add 5 here, it's gone. When I add 5 over here, I'm going to write it with a common denominator. Right? 15/3 is equal to 5. And so now my equation is going to be y equals 8/3 x, negative 16 plus 15, that would be a negative 1. There's my linear equation with those function values. Okay, so really it's not anything new, it's just a different way to ask the question. So you guys will see some of these on today's homework. The second thing they're going to ask us to do today is to use our graphing calculator to graph some of the basic functions. Again, this is an exercise that's really just about becoming comfortable with the graphing calculator and making sure we're showing a complete graph. So, and later on what we want to do is these basic functions, we want to be able to graph them easily without the graphing calculator. We actually want it to be an easier task than reaching for a calculator. So let's try this one. We want to graph with the graphing calculator. So I'll just say with the G-Calc. I've got f of x equals a negative x squared plus 3x minus 5. Let's go ahead and just produce a quick picture of what that looks like with your calculator. All right, so here's my graphing calculator. I'm just going to go to y equals and punch in that equation. Now, when you start off with a negative, that means this negative key, not the subtraction button. Okay? You would never begin anything with a subtraction button because it means you already had something and you're subtracting from it. I don't have that here. So a negative x squared. You can either do the caret with a 2, or there actually is an exponent of 2 right here. And so we can use that if we want. Plus 3x minus 5. So I hit graph. I know from past experience that whenever I see an exponent of 2, that what I'm graphing is a parabola. We should all know that this is going to flip the parabola upside down, which I see that right here. And parabolas just go on forever, so really I've got my complete graph right there. Now if you wanted to adjust the window so it took a little more of the screen, I might get rid of some of this negative part over here. You know, maybe I go from -3 to +4. And, you know, maybe from -8 to 1. So I could adjust this window a little bit. Make that a -3. And I'm going to make this a +1. And it still takes up about the same thing. But this is fine. This is a good picture. So I've got my calculator window. I went from -3 to +4, and I went from -8 to 1. And my picture, you know, it looks like most of this is sitting down in the 4th quadrant, crossing the y-axis, 1, 2, 3, 4, right about 5. You know, so I'm just going to draw a picture that kind of looks like what I see here. I also look to see where we're hitting the edge of the screen, and so really right there and right about here. So let's just draw a parabola that looks like it's doing that. There it is. I've done what they've asked me to. You guys try this one. F of x equals a negative, and then in parentheses I've got x minus 2 cubed plus 1. Use your graphing calculator to graph that function. Alright, so I'm going to go back to my calculator. We'll punch in a new function. We'll clear this one out. I've got a negative and inside parentheses x minus 2. That whole thing is raised to the 3rd power. Remember to arrow out of your exponent. And then plus 1. My calculator's older, so I don't get a true picture of what that looks like. And I'm just going to go ahead, I'll go zoom option 4 just to see what I get. That's not a bad graph right there. Okay, I don't need to see all this stuff, so maybe I'll change my window just a little bit. I'll go from -1 to 4, and from -3 to +3. And remember, the only reason I'm getting rid of those decimals is it just makes it a little bit easier to label everything over here. So there's my picture. So I'm going to go ahead and draw a calculator window. My x-axis, or my y-axis I mean, is over here. My x-axis is pretty much centered. And I went from, I'll go back and check my window here, -1 to 4 and -3 to 3. So this, this point right here, where you can kind of see we've got this curve that, like if you're driving along this road, you know, you're kind of steering to the left a little bit, but then all of a sudden you straighten out and then you turn to the right. The point at which the direction you're turning changes, we refer to that as a point of inflection. We'll talk more about that later, but that's kind of a key thing here, is to realize where that point should be. Looks like it's at 2, 1. So if this is 4, there's 2 and up, so maybe right about here. And I just want to come down, go through there, and then turn and head the other direction. Okay. Now one question that we should be asking ourselves is, how do we know that this just goes on forever? Like, how do I know it doesn't turn and come back down over here, right? Or how do I know this doesn't turn and come back up? I think we want to make sure we know that. And so if I went and did zoom, option 3, I'm going to zoom out. I just want to zoom out a little bit and see if that thing does turn around and come back. Okay, so I'll zoom out a little bit. I don't see it coming back yet. Out a little bit farther. Okay, now it's still going up and down. I'm going to go to my window and change these back to -1 and 4. But I've got some pretty large y values. So yeah, this is going up, this is going down. Maybe I should make that go a little farther, so let's go -2 and 6. Yeah, I don't see those curving and going back. And later on, we'll be confident of that. We'll look at this and we'll go, a cubic function, I know what that looks like. It looks like this. It's just that negative sign has flipped it over. So I know it goes up forever and down forever. All right? This is a good picture right here. So this next thing that we need to talk about is something new and different, I believe. And it's called the greatest integer function. And it looks like this. Y equals, what I do is I make what kind of looks like a double bracket. It's a single bracket, but then an extra line running up and down. And it looks like that. Okay? And what it means is, what is the largest integer less than or equal to this number right here? What is the greatest integer? So what's an integer? Those are numbers like 1, 2, 3, 4, 5, 6. 0 is an integer. -1, -2, -3, -4. Those are integers. No decimals, no fractions. Okay? What is the greatest integer less than or equal to x? Okay? This number right here. So if I plug something in, what's the largest integer less than or equal to that? So let's just do a couple examples here real quick. Let's say I've got the greatest integer function of 2.1. What's the greatest integer less than or equal to 2.1? 2, right? What's the greatest integer function of pi? The largest integer less than or equal to pi? 3. Sometimes this kind of gets people. What's the greatest integer function of 5? I want the largest integer less than or equal to this number right here. That's going to be 5. Sometimes people will say 4 because they think they're always going down. They're just always moving backwards. But it says less than or equal to whatever's in there. Okay, so if it's already an integer, then that is the answer. What about this? The greatest integer of a -3.571. I usually get people here, because a lot of us would go, negative 3. But is negative 3 less than that number? No, it's not. If I make a number line, and here's 0, 1, 2, 3, 4, here's negative 3, here's negative 4, this number is somewhere right about there, right? Negative 3.571, just a little bit more than halfway this direction. Well, what's the largest integer less than or equal to this? It's always to the left on the number line. These numbers are all larger, they're greater than. I want less than or equal to. And so really our answer here is 4. And so there we go. So we just kind of have to be a little careful with negative numbers. I have to stop and think, if I want less than, I got to go to the left on the number line. What's the next number less than that? All right, so we're going to get asked questions like this. If f of x equals 2 times the greatest integer function of x, okay, anytime you write a number in front of brackets or parentheses, it means to multiply, and then plus 3. And they want us to figure out what's f of a negative 2.1 and what's f of pi. Okay, you guys go ahead and try that. What are each of these equal to? All right, I'll give you a second here to do it. All right, so if I'm going to plug a negative 2.1 into this, I've got 2 times the greatest integer function of a negative 2.1 plus 3. The greatest integer less than or equal to this, remember I got to go to the left on the number line, so that would be negative 3. So 2 times a negative 3 plus 3, that's going to be a negative 6 plus 3, that's a negative 3. There's our answer. All right, if I do this one, I'm going to plug in a pi, so I've got 2 times the greatest integer function of pi plus 3. The greatest integer less than or equal to 3.14 would be 3. So this is 2 times 3 plus 3. That gives me 6 plus 3, that's 9. All right, so we'll have a few problems like that today where we're just looking at something new. Now eventually this becomes one of our basic functions. We're going to have to graph this, and so that'll take a little bit of work when we get to that. But we're not worried about graphing now, we're just trying to worry about understanding what those symbols mean. The largest integer that is less than or equal to whatever we plug in. All right, so that's all we have for today. So still assignment number 5, continued. We're now on Wednesday. We're going to do page 71, 3 to 35 odd. And I think, overall this assignment probably shouldn't be too bad. We're finding the equation of linear functions. We've done that for quite a few days now. We're graphing some things on the graphing calculator again, making sure we get complete graphs, and then just this one new idea for today. All right, that's it. You guys take care, stay safe. I will see you either on Thursday or Friday. All right, bye.